Hello, and thank you for joining this webinar. This is the third webinar in our sustainability-focused webinar series, and I'm really glad to have you here. In our previous webinars, we explored the drivers for product sustainability, including the eco-design for sustainable product regulation and the digital product passport, both of which are shaping how we develop and document sustainable products. If you haven't had the chance to watch those yet, you can find the recordings on the Creatis website. Today's webinar is called Eco by Design. It's a playful nod to eco-design, but also a statement. Sustainability doesn't happen by accident. It's something we build into our products from the very beginning. Today, we'll be diving into how sustainability can be integrated into the development process in the design phase of the lifecycle, how to make informed decisions, and how business models can support circularity, because design alone isn't enough. For any new attendees, my name is Mikkel Arntoft. I'm an engineer here at Creatis who is working with sustainability in product development. In my projects, I have worked with implementing recycled plastics in R&D, performed lifecycle assessments, and developed tools for measuring circularity as a parameter in the product development process. Today, we'll explore what is product sustainability, highlighting some key principles to keep in mind when designing for sustainability. I'll present a case where we design for sustainability by applying the principles to reduce carbon footprint. And lastly, I will go into how product sustainability can be integrated into the product development process, with some pointers to how you can begin right away. Starting with product sustainability in general, let's briefly brush up on some of the main drivers. When looking at sustainability in product development, some of the main external drivers are an increasing consumer awareness, who demand transparency of the sustainable performance of products in order to use this as selection criteria when deciding between competing products. Another major driver for sustainability in products is compliance with new regulation that is pushing for more and more circular products. This happens especially in the EU, as we explored in the previous webinars. Incorporating sustainability into the development process poses some major challenges, both in the form of identifying for each product what is the optimal solution that favors both the environment and business. As we will get into later, each product must have a sustainability strategy that is in line with your company vision as well as the business model for that product. The major challenge is in the implementation, as sustainability requires knowledge and investments. Incorporating sustainability in products could mean using new materials, technologies, or design changes to meet the sustainability strategy. Besides the development of the product, the need for data on materials, product design, and other metrics can be challenging to achieve and manage, and requires collaboration throughout the supply chain. In this webinar, we will move away from the main drivers that we looked at previously and look towards managing the challenges when designing with sustainability in mind. Even when we just look at products, sustainability is a very broad topic with a lot of initiatives going on. It can be hard to navigate what is actually a sustainable product, and does such a thing even exist? Should we begin putting bamboo into our plastic or make it from fishing nets from the ocean? There's the repairability index and various other eco-labels we could choose from. Should we sell our product in a new way? Should we use wind energy in our production? Or should we just avoid selling products altogether? There can be a lot of noise or confusion from a lot of products trying to be more sustainable. And to understand product sustainability, we need to start by just taking a look at our products. This is a product as it's often depicted. Products are designed for the use phase. They're designed to fulfill a service to a certain degree in a certain context. This is where the product delivers value to the user. This means that when we develop products, we often take into account any functions that the product must have, how well it performs these functions, the energy it uses during the use phase, how much it costs to produce, the safety, and so on. And sustainability is just another parameter to be included, just like the other ones. It's not the topping on our ice cream that is added afterwards. Imagine developing a product without the cost perspective and then begin driving down the cost once the product is finished. Then it'll be extra. But if we take sustainability into account at every step along the way, it'll be part of the decisions that we make the first time around. When we talk about sustainability in products, we need to broaden our perspective of what a product is just a little bit. The use phase is not the only chapter in the product's environmental story. It is the entire life cycle, from the raw materials being extracted, the manufacturing processes, the use phase, and what happens at the end of life. This is the life cycle perspective, and when working with sustainability in products, all of these life cycle stages need to be taken into account. The life cycle as we see it here is called a linear economy. It is, we take materials, we make products, and they are disposed of. To understand what product sustainability is, we need to understand what is unsustainable about our current economy and the environmental issues that it poses. When we continuously extract finite resources, they will eventually be depleted. And the process itself of extracting these resources leads to the degradation of ecosystems. The processing of the materials into products require energy, resources, and emit substances that pollute the environment and cause global warming. As a lot of products have a relatively short lifespan, more waste is being generated, most of which is incinerated or landfilled. These are not just environmental issues, they are business risks. Resource scarcity, causing rising material costs, pollution causing carbon taxes, and potential reputational damage. We have extended producer responsibility, but we can do something about this. It's popularly said that around 80% of a product's environmental impact is influenced by the decisions that are made in the design stage. When we design the product, we decide which materials are chosen for the product and where we source them from. We decide how and where it's produced. We design a lifetime and the ability to extend this lifetime. We influence how the product is handled once it is disposed of. In a way, we design the life cycle of the product and therefore a lot of its environmental impacts. And most importantly, we're also able to design what happens to the product once it reaches the end of its lifetime. Along the life cycle, value is added to the product, which reaches the peak value in the use phase. In a linear economy, as we see here, the value is lost once it leaves the use phase, as the product becomes waste. To design products that are more sustainable, we need to retain this value in the product, its parts, and the materials for as long as possible. This is done by looping the products, the parts, and the materials back into the life cycle to remain valuable and avoid them becoming waste. This is called circularity, or a circular economy. The entire product could be reused if it remains in a functional state. If it's broken, it might be repaired to be put back into use. Maybe the product needs a larger facelift and is taken back into a production to be remanufactured to add a new value. Parts could be recovered from the products, or as a last resort, the materials can be recycled into new products. The closer the loop is to the use phase, where it delivers the value to the consumer, the more value is retained. The further back it is sent in the supply chain, the more processes are needed to restore this value. Designing for sustainability in products can be summarized as three main strategies: reduce, reuse, and recycle. The strategy to reduce is focused on minimizing impacts throughout the entire life cycle of the product, providing the same service but with less resources. This is often focused on the materials and the production phases. The reuse strategy, or as I presented here, the extend strategy, is about extending the life cycle. It's about keeping the product and its parts in use for as long as possible. And the recycle strategy is focused on keeping the materials in use by using them in new products. Examples of the reduce strategy include using recycled materials to substitute virgin materials, using renewable energy for a production, or reusing parts from old products into new products. They seek to minimize the impacts from using parts and materials that have already been in use and would otherwise become waste, or minimizing the amount of materials and energy that is used for the product. In the extend strategy, products are designed so that they are durable and remains functional and valuable for a longer time. And if it does break down and it's no longer valuable, it must be restored to a functional state by, for example, repairing it. If the extend strategy is not feasible, the last resort is to recycle the materials into new products. Not all materials are feasible to recycle, and they need to be disassembled to be sorted correctly after disposal to avoid incineration. The recycling strategy therefore seeks to optimize the product to fit the current waste management processes to maximize the value extraction and also minimize the waste generated. But which of these strategies should you use for your product? And what about the trade-offs between these strategies? Choosing the optimal strategy depends on your specific product and its context. It's important to consider where are the large impacts for my product, how is my product used, and what happens to my product at the end of life. Because once we understand the problem, we can begin finding the right solution. It's important to be aware of any potential trade-offs both within and between these strategies. The material that has half the CO2 impact might require that 2 times the amount of material is used. The product might be very durable, but it cannot be repaired if it breaks. The material might be recyclable, but it's not recycled in our current infrastructure. It might also be that you have chosen a material with a lower carbon footprint, but it compromises the durability of the material. Or it could be that you are making your product from a very durable material, but that might make it non-recyclable. These are just some examples of the trade-offs to be aware of between these strategies. How would we know if we should reduce, extend, or recycle our product? It really depends on your product. Let's take an example. Let's take plastic straws, for example. They were made from plastic and previously belonged to the recycling strategy. But littering meant that they often ended up in nature, and the recycling strategy did not work as intended. They changed the strategy from recycling to reduce instead, reducing the impacts by avoiding them becoming litter. And they are now made from paper, which has a shorter lifetime, which causes them to be soggy instead. But it does reduce the problem of them ending up in nature. Did it solve the problem? The littering still remains, but it degrades faster than plastic. Another strategy could be to extend the lifetime. We could make the straws from metal. The production impacts would be way too high for single use. So the issue is, would you use a straw that has been used before? We would need to change the entire consumer behavior around straws and how we use them. So if you go back to reduce, maybe it is a good strategy, but maybe the solution of using paper isn't. Choosing the right strategy all depends on the life cycle of your product, where the hotspots, the challenges, and the opportunities. To make the right decisions, we need to measure sustainability. If we do not measure and base our decisions on data, how will we know which option is better? We risk making the environmental performance of a product worse instead of better. Some examples of methods to measure sustainability include lifecycle assessment, which looks at the entire product lifecycle to give you an overview of where you should focus your efforts. It could be a repairability index, which measures how easy a product can be repaired based on the ease of disassembly. It could be a circularity index that evaluates the circularity of products on parameters such as recycled content, repairability, and recyclability. It can also be eco-design checklists that assesses if your product lives up to your eco-design guidelines. The way of measuring sustainability should be aligned with your product sustainability strategy. Relevant performance indicators for your product strategy must be used to guide the decision making. A popular example is CO2 equivalence, which is measured through lifecycle assessments. Currently, when you select a material, you compare the price to ensure that it meets the target cost price. In the same way, you can consider the emissions factor, the CO2 per kilo of material, and compare alternative designs in that way. In the same way, decisions on journey methods will significantly impact both repairability and recyclability, which is key circularity parameters of your product. The disassembly, repairability, and recyclability are also measurable factors based on the performance on a given set of criteria, for example. And in order to measure product sustainability, we need data to make these measurements. We need data on material emissions factors, data on disassembly performance, data on the recycling process. We need to know what we want to measure before we can start measuring it. It's also important to notice that the design alone isn't enough. We can make the perfect circular product that is made from recycled plastics. It's very durable, it's repairable, and it's fully recyclable by the end of life. But if the system is not in place to facilitate these things, the product will not fulfill its sustainability potential. Sustainability requires a business case, which is what you design your product for. If you design your product to be repaired, you will need to provide repair instructions, spare parts, and maybe even training in repairing your product. In the figure, I have illustrated the product lifecycle like we saw it earlier, from design to manufacturing, use, and disposal. Some circular business models that will enable product sustainability are circular inputs using renewable or recyclable materials that may lead to reduced costs and sales. It could be sharing platforms where the revenue is generated from selling access to a product for a certain time or uses, where the more your product is used, the more you earn. It could be product life extension, where the revenue is generated from providing after-sales maintenance, repair, or upgrading services. It can also be selling refurbished or remanufactured products that are used for a second time. Another circular business model is resource recovery, where the revenue could come from recovering resources from disposed products or savings from reusing parts or materials from older products and new products. And then we have product as a service, which could be leasing out your product entirely. Looking at the different circular business models might inspire how you need to design your product to increase sustainability. Can you replace virgin materials in a product? The packaging for eggs is often made from recycled paper, for example. Can your product be shared amongst multiple users? We see a lot of car sharing platforms where the platform facilitates sharing. Can you enable repair of your product and sell repair services? In this example, the speaker manufacturer Bang & Olufsen is facilitating repair of their speakers. Can you recover valuable components? In Denmark, we are recovering bottles and cans to be recycled. Or can you shift to offering access to your product by selling the service, for example, leasing of bikes on a subscription? How you design your product for sustainability must be aligned with your business model of your company. Let's dive into a case on product sustainability. This case was a product assessment of a motorized window opener where the customer had a target of 30% impact reduction in the product. The process of the sustainability assessment started with an assessment of the current product. It's important to understand the current product, its context, and the use phase to get insights for improvement opportunities, and also ensuring that the quality and performance of new redesign remains the same. We conducted a hotspot assessment to find the larger impacts throughout the lifecycle of the product. In this example, it's the electronics. Then we analyzed the disassembly of the product to enable circularity. Based on this product assessment, it was found where to focus our efforts. Then I used the reduce, extend, recycle framework to identify opportunities based on the hotspots and created improvement scenarios that were assessed to determine the reduction potential. The findings were then presented to inform the redesign of the new product. The product being assessed, the motorized window opener, consists of a plastic casing that is assembled with screws, containing a chain, gears, a motor, and a circuit board. If we take a closer look at the environmental assessment of the product, it was clear that the major impacts came from the sourcing phase and the use phase. If we take a closer look at the impacts of the sourcing phase, we see that they come mainly from the electronics and the polymer materials. This indicates that the raw material supply is a main focus area for reducing the carbon footprint. Besides the material impact reduction, another focus area is extending the useful lifetime of the product. Being a motorized window opener, it has a function that fulfills a demand that is present for the entire lifetime of the window it's installed into, which means that there is basis for a longer lifetime. The last focus area was the waste processing, as currently most of the non-metals were assumed to be wasted entirely. When assessing the use phase, it was found that the contribution from the energy consumption by far outweighs the sourcing, which would make energy efficiency the main focus area, but for this case, this is not assessed any further. Once we knew the focus areas, we looked to the reduce, extend, recycle framework to identify improvement opportunities. As it consumes energy during use, the overall impact could be minimized by reducing the energy consumption and favoring effective components. On a material level, the footprint could also be reduced by minimizing the amount of components and choosing materials that have a lower sourcing impact. Another approach to minimize the footprint of the product is to extend its lifetime through ensuring that it is durable and enable it to be repaired as well. Using the product for longer both minimizes the waste generated from disposing it and minimizes the resources from having to produce a new one to replace it. The impact of the product could also be reduced through reducing the amount of virgin materials by using recycled materials or reused parts, as well as ensuring that these parts are reusable for future products. Applying these strategies to the product, the following challenges were identified. The plastic type used were not recyclable and had metal stuck to it, which further makes the parts non-recyclable. The plastic type that was used for the major plastic parts had a high carbon footprint, which could be reduced through material substitution and reduction. The failure critical parts, such as the electronics, the motor, and the gears, were also identified, and some of these were inaccessible due to, for example, potting of the electronics. As we talked about before, there are trade-offs between the strategies, and it's important that when we substitute the material for a material with a lower carbon footprint, for example, that it does not weaken the material so much that it causes a failure in the lifetime instead. Turning these challenges into improvement opportunities and quantifying them, we found that substituting the plastics could reduce the overall footprint by up to 13.9%, while reduction of material use could reduce around 5%. The scenarios are depicted on the graph, with the pink line being the reduction target of 30%. It's clear that without takeback for reuse of components, multiple scenarios have to be combined in order to reach the target. However, it also shows that based on these estimations, a 30% reduction of impacts is feasible without takeback. Reusing major components such as the PCB could further reduce the impact by up to 50%. So how do you implement sustainability into your development process? There are lots of actions that you can do, from screening of sustainability regulation, defining your sustainability strategy, designing your product using sustainability principles, setting sustainability requirements, using lifecycle assessments to make informed decisions, and so on. As I mentioned in the beginning of this presentation, sustainability is another perspective that we apply to the product development, just as we do cost and safety. If we take a look at a generic stage gate development process, at the beginning in the scoping phase, the project needs to be aligned with the company's sustainability targets, upcoming regulation, customer demand, and the life cycle of your product. All of these pose sustainability-focused requirements that must be included in the requirement specification. At the initial gate, there must be a high-level sustainability strategy with requirements set in place. During the early concept phase, it's hard to measure the specific sustainability as the materials, shape, and so on have not been fully decided yet. So here, it is more important to have the guidelines to help navigate your concepts towards your sustainability strategy. This ensures that by the end of the concept phase, the concept meets the sustainability strategy that you set. Once the concept reaches the development phase, it is detailed enough so that the decisions such as material selection, lifetime, and design for circularity can be informed by eco-design indexes or preliminary lifecycle assessments. This ensures that by the end of the development phase, you have a validated solution. For the production phase, include measurement points to track the performance and be mindful of the sustainability performance when choosing suppliers. Once the product is being implemented, finish the LCA reporting and continue monitoring the environmental performance of your product. Sustainability is a multidisciplinary approach that requires a collaborative effort across departments during development and knowledge sharing for best practices. When beginning a journey, your first step could be to assess one of your current products and get to know where your major impacts are. Once you know the focus, set a target, such as carbon footprint reduction or implementing recycled content based on your insights. Use the reduce, extend, recycle framework to identify sustainability improvement opportunities and measure the sustainability performance to drive decisions during the development. Lastly, document the improvement in a lifecycle assessment of the final product. And remember that product sustainability is a collaborative process, so engage your stakeholders during this entire process. Thank you for attending this webinar on designing products with sustainability in mind. I hope it has provided you with an insight into the various aspects of product sustainability and how it can be applied to the product development process. Remember to sign up for more webinars on product sustainability. And if you have any questions, please reach out to me here on the Credis website. I'm more than happy to answer them. We are here to support you in your transition toward a more sustainable future.